Now let's see activity 2. So the details are like this. The two situations, two beakers are there. One is having mass M1, another one mass M2. That's a 250 grams first one, 1000 grams another one. Temperatures are same. Let us say that temperatures like it is 30 only, but you can take any other also, no problem, because temperature 1 equals to temperature 2 initial, right? Initial. The initial temperatures are like this. But what I want to do here is, very simple. I want to raise the both masses to have the temperature of 60. I want to have them have 60 degrees Celsius. Here is also I want to have 60 degrees Celsius. Now, if you understand, if you start giving heat, right? If you start giving heat, simply you tell me which one takes more time, or you have to keep in mind whenever we are talking about the specific heat, rate of rise of temperature, right? Rate of rise of temperature is going to be high or low. That we must remember. So if you want to know that rate of rise of temperature, simply you talk about the first one. You are giving here the Q1, you are giving here the Q2. Okay, amount of heat giving to that substance to raise the temperature of 60 degrees Celsius. Then simply you write it where it takes more time. So what you can, rate of rising temperature, where it is. So you can observe that in a second beaker, it takes more time. Here is a time, here is a time, right? So time here required less. Why it happened? Do you have any idea? So that we can say, right, based on mass, right? Here in the first case lo mass 250 gram, second case lo mass 1000 gram. That's why we can say simply Q is directly proportional to mass, because in both when delta T is constant, mean change in temperature for both, we are taking a very common value. So here first mass key 30 to 60, second case kuda 30 to 60, and delta T is constant for first case. That's why in this case, right, Q is directly proportional to mass. What we are saying, what is the meaning of that? Q1 is less, Q2 is more. Why? Here Q1 M1 is less, that's why Q1 is less. M2 is more, Q2 is more. That's why Q is directly proportional to M, Q2 is directly proportional to M2. That's why simply from these two observations, we are saying Q is directly proportional to mass. Okay, so if you want to get the same values to the another mass, 2 kg తీసుకున్నాం, another container. అప్పుడు ఏమవుతుంది? Can you guess? Yes, it requires more time than these two, because Q is directly proportional to mass. It is the first observation. Next thing what we are going to take is, we are going to take the same values, mean same magnitude of mass. What we are going to take the same magnitude means, so I will take it. So see here, two containers I'm taking. I'm taking the two containers with the same mass. I'm taking, right? Same mass. Okay, same mass. It means M1 is there, M2 is there. M1 equals to M2, that equals to same. Let us take whatever it may be, just I'm taking 1000 gram, or that equals to 1 kg. I'm taking it. But I want to rise, initially both are again same temperature. Initially, T1 equals to 30 degrees Celsius. Here, T2 equals to 30 degrees Celsius initially. But final temperature for this, I want to have for 45 degrees Celsius. For this one, I want to raise the temperature to the 90 degrees Celsius. 90 degrees Celsius. 32, 90 in this case, 32, 45 in this case. Can you guess where the rate of rise of temperature, how it could be in this case? You can guess. So what is a constant here? What is a constant here? Mass is constant, but what is not same? Rise in temperature is not same. For first case, delta T is how much for first case? 45 minus 30. For the second case, what is the delta T? Right? Delta T2, second case, delta T1 for the first case. This equals to 90 minus 30, right? These are the differences what we are seeing. 50 degrees Celsius temperature, and here it is 30 minus, 90 minus 30, it is a 60 degrees Celsius. Delta T is different. Delta T is different. Now, can you guess in the second case, right? The rate of rise of temperature in which it is going to have the more, either the first case or the second case, means first beaker or second beaker. Definitely you can understand second beaker. Why? Because delta T is more. Okay, from this what we can conclude? From this what we can conclude? So Q, amount of heat required, right? Here is also we have to supply the heat for the two beakers. Here our interest is, what about Q? Q is needed more or less. Q is directly proportional to delta T when mass is constant. Mean constant for same masses, same magnitude of mass, delta T is going to be different. Right? Delta T in the first case, what you are seeing, it is only 15. Right? In the second case, delta T is 60. That's why Q, rate of rise of temperature, is taking more in second beaker, because Q is directly proportional to delta T. Delta T is more in a second beaker. That's why Q, right, rate of rise of temperature is going to take more in a second. Okay, from this what we can write, it is a equation 2. Okay, from the equation 1 and 2, from the equation 1 and 2, what we can say, what we can write from equations 1 and 2. What is the equation 1 initially? Q is directly proportional to M when delta T is constant, and Q is directly proportional to delta T when M is constant. These are equation 1 and 2. So from this what we can find? From this what we can find? So Q is directly proportional to M and delta T. M and delta T. Okay, that value, just to remove the proportional constant, we will keep like this. Q is equals to some constant I'm keeping here, S, M into delta T. That I can rewrite like this. Q equals to MS delta T. MS delta T. So what is this S? Yeah, it has much importance. Okay, that is which we are calling since the beginning of our topic of specific heat. We are saying one thing. It depends on nature of substance. What is that nature? That nature is here. It is a specific heat. Specific heat, right? So that constant value, specific heat, S is specific heat. How can we write from this? Can you write the formula for, units for that? So formula and unit, S equals to Q by M into delta T. Okay, this is the formula for specific heat. S equals to Q by M delta T. Right? So this is the specific heat. This is the specific heat. And what about units? What about units? You can see that. Units of specific heat. Units. Units. So S equals to, what is written? Numerator emundi Q and Joule. Joules per mass is there. Kg, temperature I'm writing in Kelvin, joules per kg Kelvin. That is a value. So joules per kg Kelvin, specific heat unit. And what about this, the definition from this equation only? If you give the definition, what it becomes? So let us understand what it is going to happen in the definition form whenever we write, right? The specific heat of substance is like it is similar to the calorie, but there is a small difference. The amount of heat required, the amount of heat required to raise the temperature of unit mass of substance. Unit mass of substance by 1 degree centigrade. 1 degree centigrade. So whereas you remember, just if you remember the calorie, what is that? It is a unit mass of substance, you said. But there you can see that unit mass of water is 1 gram of water is unit means 1 there in that case, calorie. But here unit mass of substance, that substance may be anything. So that definition, that is nothing but what? Specific heat means simply oka unit mass of substance ki 1 degree Celsius temperature పెంచడానికి మనం ఎంత హీట్ ఇవ్వాలో దాన్ని ఏం చెప్తున్నాము అంటే ఇట్ ఈస్ ద స్పెసిఫిక్ హీట్. సో దట్ SI యూనిట్ లో ఇందాక చూసాం, అక్కడ ఆల్రెడీ రాసాం, జూల్స్ పర్ కేజీ కెల్విన్, రైట్. CGS లో చూస్తే, ఇఫ్ యూ సీ దట్ ఇన్ CGS, వాట్ యూ విల్ గెట్ ఇన్ CGS సిస్టమ్, ఇక్కడ జోల్ ఉంటే అక్కడ కెలోరీ వస్తుంది, పర్ కేజీ ఉంటే ఇక్కడ గ్రామ్ వస్తుంది, అండ్ కెల్విన్ దగ్గర ఇక్కడ డిగ్రీ సెల్సియస్ వస్తుంది. సో calorie per gram degree Celsius. Okay, whenever these say units have come, SI and CGS, it is our conventional part to think relation between those two, right? Ela rastamu, let us see that relation between SI units and CGS units. So what is that? You can write here like this. What you can write? Calorie per gram degree Celsius equals to, okay, 1 calorie equals how many joules? We know that 4.186. In the previous video we have seen that. If you want to know that how it is, you can go back and you can see that once. And gram is there, and that should be in kilogram. So then what we do, that we convert with dividing with 1000 into, then it becomes kg. Now Kelvin, delta T is there, right? Delta T. So degree Celsius and Kelvin relation also we found there. So conversion factor చూసాం, కానీ ఇక్కడ ఆ వాల్యూ ఏమి తీసుకోం. ఎందుకు అంటే డెల్టా టీ ఉన్నప్పుడు అది డిగ్రీ సెల్సియస్ లో ఉండని లేదా డిగ్రీ కెల్విన్ లో ఉండని, ఇక్కడ వేరియేషన్ ఏమీ రాదు. ఎందుకంటే కామన్, సో లోయర్ వాల్యూకి హైయర్ వాల్యూ కూడా కామన్ వాల్యూని మనం యాడ్ చేస్తాం, కాబట్టి అక్కడ డిఫరెన్స్ రాదు. దట్స్ వై వీఆర్ నాట్ గోయింగ్ టు టేక్ ఎనీ కన్వర్షన్ between degree Celsius and Kelvin in this formula. That's why what it is going to happen, 1 calorie per gram degree Celsius equals to, so if you write it, what it happens, so 4.186 into 10 to the power of 3 joule per kg Kelvin. This is the important fact, right? The conversion, whenever you are talking about what? Specific heat. When you are talking about specific heat, this is the reason. But the question is, why each? Okay, ఎందుకంటే అలా చెప్తున్నాము? ఒక టీచర్ సేమ్ క్లాస్ చెప్తుంటే కూడా ఒక్కొక్కలా ఉన్నారు స్టూడెంట్, ఏమంటే సింప్లీ వీఆర్ సేయింగ్ నేచర్ ఆఫ్ దట్ స్టూడెంట్ అంటున్నాము అంటే దానికి రీజన్ ఉండాలి కదా, ఎందుకు నేచర్ అంటున్నాము అని. బట్ అది చెప్పవచ్చు, అది ఎగ్జాంపుల్ కాబట్టి. బట్ ఇక్కడ మన క్వశ్చన్ ఏంటంటే, why is the specific heat different for different substances? Different substances. Do you remember what we discussed in the activity 2? So we have said 2 or 3. We have said kinetic energy, average kinetic energy is directly proportional to absolute temperature. Absolute temperature, right? So if you remember that, whenever you are giving the heat to the substance, how that heat is going to be used. Suppose, let me give you the idea for water. If you have taken one water, right, that water contained molecules. Okay, it contained different molecules. Whenever you give the heat, how this heat is going to be used, for what purposes the heat is going to be used? Simply, I'm going to say that it is internal energy. Internal energy. What is that internal energy of the substance? You have to understand that internal energy. There are many various kinds of energy forms. So what is that? Linear kinetic energy, linear kinetic energy, angular kinetic energy, angular kinetic energy. Next, vibrational energy, vibrational energy, right? It is a vibrational energy. And potential energy, potential energy. So whatever we have given heat, right, in the very beginning, from the very beginning onwards, we are talking as the heat is a form of energy. But that energy given to the substance used by what? Used by what? These various forms of energy is used. ఒకవేళ మనం ఇచ్చిన heat Q అనేది heat ఇచ్చాము. Q is used for these 4, right? For these 4. So 1, 2, 3, 4. One is linear kinetic energy. Second one, angular kinetic energy. Third one, vibrational energy. Fourth one, potential energy. ఇచ్చిన హీట్ అనేది, ఇచ్చిన హీట్ మనం ఏదైతే అమౌంట్ ఆఫ్ హీట్ ఇచ్చామో అది లీనియర్ కైనెటిక్ ఎనర్జీకి యూజ్ చేసుకొని ఉంటే ఏమండేది? రైజ్ అనేది త్వరగా జరిగింది. Rate of rise of temperature is very quickly, because we already just now remember that point also. So average kinetic energy, average linear kinetic energy is directly proportional to absolute temperature. So ikkada emautundi, why some having the more specific heats, ante ichina Q except that ఏమైంది అంటే ఈ 3 purposes కి యూజ్ చేసుకున్నాం. 3 purpose అంటే 3 forms of energies యూజ్ చేసుకున్నాం. ఏంటి? ఇచ్చిన హీట్ ఒకవేళ 100 joules అనుకోండి, 100 joules of heat ఇచ్చాం. ఇక్కడ ఓన్లీ ఇక్కడ 10% ఇచ్చాయి, 10 అంటే 10 joules of energy given to the linear kinetic energy. Remaining 90 joules of energy is taken to the angular kinetic energy, vibrational energy and potential energy. That's why temperature rate of rise of temperature is not happening quickly. If reverse think change, ఇచ్చిన 100 joules of heat 90 joules వచ్చేసి లీనియర్ కైనెటిక్ ఎనర్జీకి సప్లై అయింది అనుకుంది, అప్పుడు ఏమవుతుంది? సో ఇఫ్ యూ థింక్ దిస్ average kinetic energy is directly proportional to T absolute అని గుర్తు వస్తే, ఓకే, కైనెటిక్ ఎనర్జీకి మోర్ అమౌంట్ ఆఫ్ హీట్ తీసుకుంది కాబట్టి టెంపరేచర్ రైజ్ అనేది ఏమవుతుంది? ఎక్కువ అవుతుంది. అంటే రేట్ ఆఫ్ రైజ్ ఆఫ్ టెంపరేచర్ ఎక్కువ అవుతుంది. సో ఇట్ డిపెండ్స్ ఆన్ ఇంటర్నల్ ఎనర్జీ. So what that means? That internal energy is nothing but all these sum of energies. అందులో కూడా ఈ దేనికి ఎక్కువ పోర్షన్ తీసుకుంది అనే దాని మీద డిపెండ్ అయి ఉంటుంది. దేనికి ఎక్కువ సబ్స్టాన్స్ అంటే స్పెసిఫిక్ హీట్ వాల్యూస్ ఉన్నాయి అని. సో దిస్ షేరింగ్ ఈజ్ డిపెండ్, రైట్? షేరింగ్ దేనికి ఉంటే స్పెసిఫిక్ హీట్ ఎక్కువ ఉంటుంది, తక్కువ ఉంటుంది, ఆ కాన్సెప్ట్ ని మనం అర్థం చేసుకోవాలి, రైట్? రేట్ ఆఫ్ రైజ్ ఆఫ్ టెంపరేచర్ more or less, that we need to understand. So that's why it is depending on what? It depends on its substance. ఎందుకు సార్ కొన్ని కాన్సెప్ట్ లో ఎక్కువ షేర్ చేసుకున్నాయి, కొన్ని సబ్స్టాన్సెస్ తక్కువ షేర్ చేసుకున్నాయి, ఇందులో వేరియేషన్ ఏంటంటే దట్స్ నేచర్ ఆఫ్ దట్ వన్. వై సమ్వన్ పేడ్ మోర్ అటెన్షన్ ఇన్ ద క్లాస్, వై సమ్వన్ పేడ్ లెస్ అటెన్షన్ ఇన్ ద క్లాస్ మీన్స్ దట్స్ దేర్ రైట్ నేచర్. దే ఆర్ డూయింగ్ లైక్ దట్. Substance also behaving like that. That's why the specific heat is going to be different. But to understand that, S equals to Q by M into delta T. So S value ఎక్కువ ఉంది అనుకోండి, specific heat value ఎక్కువ ఉంది అనుకోండి, delta T rise of temperature ఎక్కువ ఉంటుందా తక్కువ ఉంటుందా? You can see that S and delta T, it is inversely proportional, right? High specific heat ఉంటే, హై స్పెసిఫిక్ హీట్ ఉంటే ఏం చేస్తాము? రైజ్ ఆఫ్ టెంపరేచర్, ఆ రేట్ ఆఫ్ రైజ్ ఆఫ్ టెంపరేచర్ విల్ బి లో. ఇట్ ఈస్ గోయింగ్ టు బి లో. ఇఫ్ స్పెసిఫిక్ హీట్ వాల్యూ ఈస్ more. So that if you want to understand, it is given in the table in your textbook. You can see that. I'm taking the examples too. One is lead. So that lead value is 0.031 calorie per gram degree Celsius. Whereas water, I'm taking water. That water is having the value of 1 calorie per gram degree Celsius. Now, can you tell me, ఈ రెండిటికి సేమ్ అమౌంట్ ఆఫ్ హీట్ ఇచ్చాం, ఈ రెండిటికి 100 joules of heat ఇచ్చాం. ఏది ఎక్కువ రైజ్ అవుతుంది టెంపరేచర్, ఏది తక్కువ రైజ్ అవుతుంది టెంపరేచర్? కెన్ యూ గెస్? యూ కెన్ సే దాట్, రైట్? వాటర్ ఈస్ హ్యావింగ్ 1 value, it is a more, right? Specific heat is more. That's why rise will be very low. Whereas lead, it will have more rise of temperature, means very quickly rate with respect to the time we are talking rate, right? Rise will be rise quickly. So here rising happen, rise of temperature very slowly. Are you getting? So this is the nature why it happens, what based on what parameters the specific heat is different. So 2 examples we have seen. One is the lead, another one is water. So water has the highest specific heat value. So because of this, in many areas it has its own advantage. What are those advantages? We will see that in the next videos. I hope that you are clear about specific heat, right? So thank you. If you like this explanation, and if you understand, you can like and share, subscribe the videos. Okay.